Moving on from the ST segment, let's move into the T wave itself. If we just isolate the T wave, your T wave should be asymmetrical. So if we split it in half, peak to bottom, split it in half, left to right, it should look different. Should have different pieces. Shouldn't be the 50-50 T wave. Should be asymmetrical. An asymmetrical T wave, a completely normal, that's what we want. That's what we want to look for. If we have a symmetrical T wave, then we're running into issues, running into problems. We might have some cardiac ischemia. We might have some electrolyte issues, specifically potassium issues. And we also see symmetrical T waves with central nervous system, intracranial hemorrhage, increased cranial pressure problems. So our T waves should be asymmetrical. It doesn't matter where the ST segment is, right? Our T wave should be asymmetrical. So if I drew a vertical line through the peak of our T wave, split it in half, left side, right side should look different. If I have a symmetrical T wave, so I split it in half, left to right, down the middle, and I have two equal halves. That's a symmetrical T wave. Something weird is going on. There is something abnormal going on with your patient. T waves come in all shapes and sizes. They're asymmetric or symmetric, right? We can be positive, we can be negative, we can be tall and peaked and narrow, we can be tall, peaked, and broad, we can be like super broad and positive, and really, really broad, negative, right? So we're going to be looking into some T wave issues. Again, you want your T wave to be asymmetric, but what happens when it's symmetric and tall and peaked? We've got some weird stuff going on. So pay attention. We're going to be paying attention to our T waves. Your T waves should be positive and leads 1, 2, and then in our precordials are V3 through V6. In the other leads, they can be negative, they can be biphasic, they can be positive, they kind of fluctuate a little bit, but in those leads, they should be positive. And when we have a T wave that is negative, that is negatively deflected where it should be positive. So I'm looking at lead 1, my T wave should be positive. But if it's a negatively deflected T wave, I'm going to say that T wave is flipped. So I have a flipped T wave. I've got this negative T wave. And that's typically a sign of either ischemia or, remember, if we think back to that ventricular strain pattern, so it could be a sign of ventricular hypertrophy. So we need to be paying attention. So I see a flipped T wave. Well, why is that T wave flipped? Is it ischemia or is it ventricular hypertrophy? In terms of amplitude, our T waves we've got a couple criteria for our T waves. In the limb leads, no more than 6 millimeters high. In our precordial leads, no more than 12 millimeters high. But what we're really paying attention to is the T wave in respect to its QRS complex. So it shouldn't be more than 2/3 the height of the R wave in which it's associated. So you might have a really tall T wave, but do you have a really tall QRS complex? So maybe following, so if you have a really tall QRS complex, you need a really tall T wave to repolarize that depolarization, right? We're seeing the same thing just in reverse. We're seeing a really big depolarization and a really big repolarization, but in respect to each other, the proportion to each other, that T wave is greater than 2/3 of the height of the R wave, we've got an issue. So really tall T waves, we're thinking ischemia, possibly myocardial infarctions, these CNS events, right? So brain hemorrhages and potassium levels. So hyperkalemia is going to cause some funky stuff with your T waves. So let's look at this EKG, and some stuff kind of pops out at us, right? So sinus rhythm, normal sinus rhythm. Looks like normal axis deviation. I don't have any bundle branch blocks. What about left ventricular hypertrophy? I might have left ventricular hypertrophy, right? So let's count it out. Left ventricular hypertrophy. I've got 5, 10, 15, probably 20. included there. V5 looks taller than V6. So 20, 25, 30, 35. Yep, we've got left ventricular hypertrophy. There we don't have right ventricular hypertrophy. I don't see any atrial enlargements. I don't see left atrial enlargement. I don't see right atrial enlargement. But everything that just looks kind of big, and these T waves kind of pop out at us a little bit. But these T waves are asymmetric. If I drew a line straight through the peak, right, we've got this little swoop up into it that makes it asymmetrical. So that's a good thing. And then even though they're big guys, they are not more than 2/3 the height of this R wave. So I've got a big R wave. I've got these big complexes, right? Because of my left ventricular hypertrophy. But I also have a big repolarization. So even though these T waves are big, they're not pathologically big. So they look big, they kind of jump out at you, but it's because of the left ventricular hypertrophy, and the T waves themselves are nothing to be concerned about. This EKG, let's walk through this one. So again, sinus rhythm, normal axis, lead 1 is up, AVF is up, bundle branch block, nope, don't have a wide QRS complex. Left ventricular hypertrophy, maybe. Let's look at lead 1. Lead 1's a little tall. 5'10". Yeah, look at lead 1. So lead 1 shows left ventricular hypertrophy. I don't see it in the precordials, but we see it in lead 1. So we have left ventricular hypertrophy. There we go. What about right ventricular hypertrophy? So I'm looking for more positivity than negativity in the QRS complex in V1, V2. And V1, nope. V2, yep. So I have right ventricular hypertrophy. So I've got both right and left ventricular hypertrophy. Bully for that guy. What about atrial enlargements? So I don't see any. You might be able to. I think we could argue for left atrial enlargement. The P wave in lead 2 looks a little bit wide. Looks like we might have a little bit of a hunk to junk, a little notch here in the P wave in lead 2, so maybe some signs of P mitral. Look at V1. Definitely a biphasic P wave, and we could again argue for that second part, that negative part of the P wave being a little bit larger. So we've got signs of left ventricular hypertrophy, we've got signs of left atrial enlargement, we've got signs of right ventricular hypertrophy, but here we are focused on our T waves, and they are flipped all over the place. Holy moly. And what is this? Well, this is a right ventricular strain pattern. I've got right ventricular hypertrophy, a ST segment depression is below baseline, and a flipped T wave. So why is my T wave flipped? Well, it's because it's a right ventricular strain pattern because we have right ventricular hypertrophy. Okay, what about this third EKG? Oh my god. What's going on here? There's so much going on. So first, rhythm. What is the rhythm? We're going to give you a second. I'm going to take a sip of water. Well, you look at this. Okay. So what's rhythm? Slow. If you said slow, well, slow is not a rhythm. Congratulations. So what do we see here? I see QRS complexes. QRS complexes are fairly, they're super slow. You're right. Really slow, but regular. Let's look down at the bottom. This running lead 2. QRS, 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 QRS. And then all these like little guys in between. All these P waves. Look at all these things. All these P waves. Our P waves are regular as well. Imagine that. But our PR intervals are irregular. So we have a third degree AV block. That's our rhythm, third degree AV block. What's our axis? Lead 1 is up. AVF is mostly up. We have normal axis. We're happy there. Do we have a left or a right bundle branch block? We do have a wide QRS complex, but we don't have a bundle branch block. But wait, why? Wait a minute. We have a wide QRS complex, but why don't we have a bundle branch block? It's because these QRS complexes in a third degree AV block are being produced by the ventricles. That's why they're wide, not because of a left bundle branch block, because it's a third degree AV block. It's a ventricular. These QRS complexes are ventricular. We just happen to have some P waves in between, right? AV dissociation. So we're not going to document bundle branch block. We're going to say, yeah, third degree AV block. That's why it's wide. Ventricular hypertrophies. We're going to throw that out the window. It's a ventricular. We've got ventricular complexes. We're going to throw that out the window. Atrial enlargements. We don't really need to worry about that right now, do we? Maybe, but is left atrial enlargement really this guy's biggest concern? No. So we're also going to skip over that. Not a whole lot of sign of any atrial enlargements anyway, but all these P waves are probably coming from different foci, and it's kind of hard to see. So we're going to move on. What about these T waves? These T waves are just like huge and ginormous and like whoa and wait a minute and whoa. And they're flipped and they're big and they're peaked and they're everywhere, right? So we've got a third degree AV block, and we have a T wave issue on top of that. So might be an electrolyte issue, might be a CNS issue, a neurologic issue. So that's probably what's causing this AV block. All right, let's move on from that and talk about a different type of T wave, and we're going to call this the tombstone T wave. Super morbid, but that means your patient is about to die. So if we see this tombstone T wave, so this really big, super elevated ST segment going into this flipped T wave is telltale sign for huge myocardial infarction, huge heart attack. You see this, it's going to jump out at you. It's going to jump off the page at you. And this is the point for you to go, you know what, we're going to do some things really quickly. And we're going to call a code STEMI really quickly to the hospital and get the cath lab team activated, because this is a big old heart attack, big old MI, your tombstone T wave. Here they are in practice. I bet you can't see them. Where are they? Your tombstone T waves are hiding. Your tombstone T waves never hide. Oh my lord. So V1, V3. Look at that. Big old ST segment elevation. Here's your J point right up here. So big ST segment elevation going into this flipped T wave. So V2, V3. You see the same thing, right? We've got elevation elsewhere, but your tombstone T waves are right here. Again, these are going to jump off the page at you as soon as you print these out. As it's printing, you're going to go like, "Oh no." Don't say that. Don't say that out loud. Say that in your head. So in your head, you're like, "Oh no." Right? So tombstone T waves jump out at you, and telltale sign for a pretty large heart attack. Well, what if maybe, I don't have tombstone T waves? I've got these like flipped T waves and this like weird ST depression. Well, we're going to call that ischemia. So I've got ST segment depression. It's below baseline. My ST segment's below baseline. And I've got this flipped T wave. So your ST segment might be flat going into this flipped T wave, or it might kind of slope down into this flipped T wave. So both of these, we're going to call this ischemia. And where do we see ischemia? So here we're seeing ST segment depression. Here I've got lead 1, I've got AVL, and I've got a V2. I've got it over here, V4, V5, V6, right? A little bit in V3, right? So I've got this ST segment depression into this flip T wave. And we're going to call all of that, we're going to call that ischemia. So as you're working on your assignments, and it says, where do you see on this EKG ischemia? What regions do you see ischemia? And you're going to say, you know what? Lead 1 in AVL. And 5 and 6, those are the lateral regions. We'll get to that in a little bit, but that's where I see ischemia. So ST segment depression, we're going to call ischemia. On this EKG, we're seeing ischemia again, right? So ST segment depression into a inverted T wave. Here, this ischemia is because it's a ventricular strain pattern, right? But ischemia nonetheless, right? So we're still going to call it ischemia on your assignments. You say, where do you see ischemia? You say, well, I see ST segment depression in these leads. That's what we're going to be looking for. And finally, in this EKG, again, ischemia, ST segment depression, lead 2, lead 3, AVF into V5, V6, V4, just like everywhere. A little bit in V3, maybe a little bit in lead 1, right? But ST segment depression, we're going to be calling this ischemia. If you have any questions, that's our ST segments and our T waves. If you have any questions about those, reach out and please let me know.